Right. For those of you who are listening at home, I will have Randy, Josh, Peter Healy.
And
We're going
Josh.
Okay, grab a red writing utensil. Have it ready. The answers are as follows. Number one. The big fraction is negative radical 6 minus radical 2 all over 4. Number two. 2 plus radical 3. Number three. Radical 6 minus radical 2 all over 4. Number four. Radical 6 minus radical 2 all over 4. Identical to number 3. Number five. Radical 6 plus radical 2 all divided by 4. Number 6. 2 minus radical 3. And then repeats, first page. Okay, number 7. Negative 2 plus radical 3. Number 8. Radical 6 plus radical 2 all over 4. And repeats up to number 8, first section. Yeah.
Can you say 7 again?
7. Negative 2 plus radical 3. All right, number 9. Answer is radical 2 over 2. Number 10, the answer is 1/2. Number 11, the answer is negative 1. Number 12, the answer is 1. Number 13, the answer is 1. And 14, the answer is 0. And repeats. All right, questions? What do you want dissected? Go. Number 10? Yeah. Cosine of 51, cosine of 9. Plus or minus? Minus sin of 51, sin of 9.
Actually, no, you don't. I figured out what you did. Sorry, I'm just.
I got outdo you. Next? Yeah.
Number 4.
Number 4. Yeah. Cosine of negative 75 degrees. There is a long way and a short way to do this. The short way is if you've memorized the master fraction. The long way is if you want to do angle addition and subtraction. Yeah, perfect.
Second one.
Addition, subtraction?
Yeah.
Okay. Can someone refresh my memory of the cosine addition format? Take the notes if you need to. Great.
Cosine of A,
Ah,
cosine of B,
Yep,
plus or minus sine of A, sine of
almost.
B, plus, or minus or plus.
Good. Minus plus, that means you switch the sign. And then go ahead.
Sine of A, sine of B.
Sine of A, sine of B. Okay. In this particular case, let's get rid of the thing here. Can anybody find two angles that you can add or subtract? It doesn't really matter which is which. Oh, sorry, go ahead. Yeah, leave the door cracked so you can come back in. Can anybody think of two angles you can add or subtract? It doesn't really much matter. Two common angles, add or subtract at the negative 75. Sky's the limit. Just make sure they're both common. By the way, refresh my memory. Sam, what is a common angle?
Is it multiple 30, 45, 90?
Correct. Any multiple of 30 or 45 or 90 degrees. So can you find two angles that are common that add or subtract to negative 75? Go.
Negative 30, negative 45.
Negative 30 and negative 45 sound good. Cosine of negative 30 degrees plus negative 45 degrees. I'm going to deliberately use the addition formula. By the way, you can just do subtracting a positive, either way will work. Can somebody plug this in for me? For example, Spencer, go for it. Use this and plug in the A and the B. Okay, cosine of negative 30. Cosine of negative 45, okay. What would you put here? We gotta pick one. That's, basically, if you do a plus here, you do a minus here. If you have a minus here, you do a plus here, okay? Yeah, they did a plus, we do a minus. And then minus what?
Sign of 30.
Sine of
Oh,
negative 30. And then,
sign of negative.
correct. If these are common, then they're on the unit circle somewhere. Refresh my memory, please. What is the cosine of negative 30? Where is negative 30, first of all? Where do I find that?
Same spot as 330.
Same spot as 330, correct. Cosine there. Is cosine left, right, up, down, or slope?
Right,
Left, right. Is this particular one left or right?
right,
It's to the right. A lot or a little?
left,
A lot. So what's the cosine?
radical third of 2.
It is radical 3/2. What is the cosine of negative 45? Start from beginning. Let me see. Abby, negative 45 degrees, where is that?
The same spot is,
What quadrant is it, first of all?
oh, the fourth.
Fourth quadrant, okay. And it's a multiple, well, that's a stupid question, but multiple of what? Yeah, it's a multiple of 45. So, ta-da. What was that the same place as? Sorry. Here's 270 if that helps.
300.
300 and, that's 30 degrees over. 330 is 60 degrees over. 315. Very good. Okay. Now, the main thing, you don't even have to know where that is. Cosine, refresh my memory. Left, right, up, down, or slope?
Left, right.
Is this one left, or is it right?
Right.
It's to the right. What's the fraction that goes with multiples of 45?
Radical 2/3.
Bingo. Radical 2. Minus something times something. Awesome, take over. What is the sign? Where is negative, well, here's the negative 30. What's the sign at that point?
Would that be negative 1/2?
Yeah, explain why it's negative.
Since sign is up, down, it's below the, well, it's down, so.
Yeah, it's down, basically. Is it down a lot or a little?
A little,
A little. What would it have been if it had been a lot?
radical 3/2.
Radical
Negative
32.
radical 3/2.
Yeah. So what did you say it was?
Negative 1/2.
Negative 1/2. Don't change the minus sign, the subtract sign here. The negative 1/2 is by itself. And sine of negative 45. Go, Courtney.
Would it be negative or?
It would indeed. Why?
Because sign of down, is down.
Yeah, and the only fraction for radical is radical 2/2 for sine and cosine. All right, somebody put this mess together. Beautiful stuff. Together. Mary Claire. Good. Minus. And then what's negative times negative? Positive. Positive what? Over. And then mush it all together. Okay. Nice. Questions? Next. That's a good one. Any others? Yeah, Katie. Number 12. Tangent of 65 minus tangent of 20 degrees all over 1 plus tangent of 65 tangent of 20. Now, refresh my memory on the tangent addition formula. Who has that one? Go. All right.
Tangent A plus or minus B.
Good. Plus or minus tangent of B. And then over what?
Tangent,
Yeah, you're right.
over 1 minus or plus tan A or tan B.
Tangent of A, tangent of B. Nice. Tangent of A, tangent of B. This thing here Does it look like they used an addition or a subtraction for the original formula? Yeah. And then tell me how you know. Look at here and look at which sign they chose. They did subtraction, why'd you say that? Yeah, the plus minus has to match. And then the other one has to be the opposite. So good. So we did the bottom candidates. So if they're subtracting, tell me what this is really. Yeah, tangent of 65 minus 20. That's tangent of 45 degrees. Common or uncommon? Common. Multiple of 30 or 45, duh. Multiple of 45, but what is tangent of 45? It is 1, correct? And that is your answer. Right. Thanks so much for being here. Darn it, I wanted to catch it between my fingers. Oh, well, okay, count my blessings. Yeah, no, he's from, I didn't get a chance to tell you, I didn't expect him to come stampeding in before class started. There was Dr. Copeland, he was from, Hillsdale College. He's visiting and seeing how we do things in the powerful math world. All right, next. Any others? Any other things you stuck at? Feeling kind of comfy with this? Think you could do it on a test? Slide in. Going once, twice. So, take out your notes, please. I want to refresh your memory. I'm going to give you some time to work today, but I want to refresh your memory on the double angle and half angle formulas. There are a few that I didn't give you yesterday that I want to give you today. I want to give them to you in one big cluster. The first one, the sine of 2a. I'm just going to put them in one list so you can find them all. The sine of 2a is 2 sine of a cosine of a. We did that yesterday. Do you remember what the trick was where we got that formula? Like, what did we do in order to get 2a? There's a trick to the go. Yeah, we did a plus a in the sign addition formula. Now, I do have to point out cosine of 2a. Does anyone remember the first formula, the one that's kind of easiest to remember? It looks a lot like master formula number 1. Awesome.
It's like cosine squared a minus sine squared of a.
Correct. Now, it does make a difference which one you put first. Master formula number 1, it doesn't matter if sine or cosine comes first. This one you have to be cosine first. But if you think of cosine first, if you think sine first, sine first. Now, there are 2 variations. Can anybody tell me the first one? We were using it yesterday. Go.
Cosine of A, cosine of A, minus sine of A.
That's actually true. That's absolutely true. That's an uncondensed version of this. We had done a substitution with sine squared. Then we have that in us. We can do it again if you don't. But go, spend it.
Cosine squared cosine 2a equals cosine squared a minus parentheses. Well, is this right?
That is true, although there's a simplified version after that. Yeah, go ahead.
Cosine of 2a equals 2 cosine squared of a minus 1.
Yeah, 2 cosine squared of a minus 1. You were right, by the way. That was the right formula. Just to refresh your memory, if sine squared of a plus cosine squared of a is equal to 1, then cosine squared of a would be equal to 1 minus sine squared. And, there's right over here. And sine squared of a is equal to 1 minus cosine squared. So if you see, like, visually where that comes from? Like, you just subtract sine to the other side, or subtract cosine to the other side. These come in handy in the strangest places. show you more on these tomorrow. But for now, you can substitute cosine squared, or you can substitute sine squared. Let's just say we have cosine squared of a minus sine squared of a. I think I did plug in the sine squared. So it's cosine squared of a. If you already have this in your notes, you don't have to write it. If you don't have it in your notes, you might want to write it down, because this is how we got the original formula. Minus, and then just replace this. Then this will distribute. This will be, so it becomes cosine squared of a minus 1 plus cosine squared of a, which is, I think, what you're talking about. And then these are like terms. 1 cosine squared plus 1 cosine squared is 2 cosine squared. Minus 1. That's what it is. So what happens if you plug in the other one? What if you plug in cosine squared? Like this stuff. It would be 1 minus sine squared of a minus sine squared of a. These are actually like terms. You don't really need the parentheses. This is 1 minus 2 sine squared of a. There's the third formula. That I did not give you yesterday. So you want to write that down at least. Here are the 3 formulas we need for cosine of 2a. This is the most common one, and these are the 2 variations. Now, why do we care? I mean, those are nice. It just seems like we're sort of playing with things. Let me do it over here. This formula number 2 has a lot of use. Let me do this. Cosine of 2a, cosine of 2a. Or. So there are 3 different versions, and the middle version actually comes in really handy. The reason is because it has nothing but cosines in it, which is kind of a lot nicer than the others. I'm going to recopy it over here. Cosine of 2a equals 2 cosine squared of a minus 1. Does anyone remember the trick? It's one step. It's a very weird step. But one step where we can get this down to what we call a half angle formula. Instead of a, I want a over 2. What do you do to both sides? See if you remember. It was near the end of the hour. Here's the trick. I should put parentheses around here. Divide the input by 2. That is legal as long as you do it to both sides. Here's what it looks like. Cosine of 2a over 2 equals 2 cosine squared of a over 2. So the inputs, divide them both by 2. You can do that as long as you do the exact same thing to both sides, it's legal. If you multiply the outputs by 2, legal. Multiply the inputs or divide the inputs by 2, legal. Just simplify it. It should be cosine of regular a equals 2 cosine squared of a over 2 minus 1. And yesterday, right at the end, I want to get this cosine of a over 2 by itself. Because this is called a double angle formula. These are the formulas. Oh, did anybody not get the tangent double angle formula from yesterday? Did anybody go on yesterday? Okay, so go. Let me write down the tangent formula before I forget, sorry. Tangent of 2a is equal to 2 tan, well actually, let me just show you where it comes from. It's tangent of a plus tangent of a over 1 minus tangent of a times tangent of a. Can somebody simplify that for me? It does simplify a little bit. Sam, tell me, what's the dot?
Two tangent of A.
2 tangent of A, good. I don't think I gave anybody this. Over,
It's 1 minus tangent of A squared.
yes, 1 minus tangent squared of A. That's the double angle formula for tangent. Okay? Now, if I can get cosine of A over 2 by itself, cosine of 2A is called a double angle, because it makes the angle double. This would be called a half angle formula, where you can cut the angle in half. Add 1 to both sides, that's what we did yesterday. So cosine of A plus 1 equals 2 cosine of square root of A over 2. Take over Megan. I want to get cosine of A over 2 by itself. What do you do next? 2 things you have to get rid of. Oh, and technically this is written like if that helps. I just want this by itself. Yeah, divide by 2, first of all. So we now have cosine of A plus 1 all divided by 2 equals cosine of A over 2 parentheses squared. And then one more step. How do you get rid of the square? Square root, correct. Plus or minus cosine of A plus 1 over 2 equals a half angle formula. And again, there's a little bit of a trick here. You have to pick one, whichever works. You know, square roots only normally have 2 answers, positive and negative. If I say find the cosine of some weird angle, let's say, here I am, 22.5 degrees. Find the cosine. How many answers does that have? This is not exactly a trick question, huh? You're getting closer. In other words, the cosine of 22.5, is it to the left or to the right?
To the right.
It's to the right. How far? I don't know. But does it make sense? There's only one distance. I think I know what you're talking about. There are 4 around the circle that have the same number value. But, okay. Well, that's right.
Oh.
Yeah. So there's only one answer to cosine. If it's to the right, I can't do plus or minus. Let's just say this is like 0.8. Let's just say this is 0.8 over, well, let's just say this is some mystery angle. And this is 0.8. Is the cosine positive or negative? Positive. Is it ever negative if it's on this side? No. So if your answer is cosine is equal to plus or minus 0.8, is that correct? Yeah.
Shouldn't it be like plus 0.8?
Right. The answer is no, it's not. It's half right, half wrong. If something says plus or minus 0.8, that's just because the square root is sort of mindlessly doing its thing. We have to choose whichever one works, because there's only one answer. Yeah.
Yours time.
Yeah, leave the door correct. Does that kind of make sense? So the first formula I'd like you to put on here, here's a half angle formulas. Here's the first one. Cosine of A over 2 is equal to plus or minus square root of cosine of A plus 1 over 2. The book, oh well, we're not using the book, so never mind. I say the book sometimes says the top backwards. 1 plus cosine of A, which is not horrible. It's okay. I do need 2 more formulas though. Sine of a half angle and tangent of a half angle. And if you'll pardon me for a second, you give me 30 seconds, I will spare you about 15 minutes worth of notes. You know what? I'm actually going to go with the books idea. Is anybody writing a pen? I'm so sorry. Could you switch this around? There's a reason. Yeah, it didn't have to, but it looks better. This is 1 plus cosine of A. The reason I'm doing this is because sine is plus minus, it's almost identical. It's 1 minus cosine of A. Let me see. Tangent is, I'm just curious if anybody knows how I got this. Where on earth did I get that? Yeah. Right, tangent is sine of a cosine. I multiply by the reciprocal. And you just take the reciprocal. The 2's will cancel, and you're left with that. So those are your 3 half angle formulas. There are some sort of much more simplified versions of the half angle formula for tangent, but for now, this should be fine. Questions so far? All right. Let me hand these things out. I'm going to give you 1 or 2 demo problems. I'll do them together with you. Sorry, people, I'm crowding your view screen there. So, this is homework 14D-1. People watching at home, I'll email this to you if I haven't already. Let's take a look at number 6. Does everybody have this stuff on the left-hand side? Where's that? Everybody good? All right. This is a double angle formula. I suppose if you get really desperate, you can watch YouTube and scroll to that part of the screen video. So here's number 6. It's kind of a mystery. We're going to do this together. 6 is this. Tangent of theta is equal to negative radical 17 over 8. And theta is in between 90 degrees and 180 degrees, not counting 180. They wrote it in the old-fashioned way, and I did it with interval notation. They want sine of 2 theta. Part of the problem is, what do I need in order to get, I just erased it. What do I need in order to get sine of 2 theta? I need 2 things. What does the formula say? I think I can get rid of this stuff now. Refresh my memory. Nate, what is the sine of 2a? Yeah, 2 sine a what? Times cosine of a. Good. 2 sine of a cosine of a. If I want to get this answer, I need 3 things. I need a 2, which is easy. I need sine of a, and I need cosine of a. Once I get those, I can multiply them and I'm done. So let me put that over here. 2 sine of theta, cosine of theta. Now, all they told me was tangent. What on earth? Now, the negative is a little weird. I'm going to show you a little bit of a trick. This is probably the first time I've ever done this. This is technically illegal, mathematically speaking. They're not going to come and arrest you, but the math police might come and arrest us. But it's not, civilly illegal. It's just mathematically questionable. Can somebody tell me? There are two possible answers.
I was gonna say, root tangent, sine.
There are two answers here. Tangent is sine over cosine. That's one possibility. Or, what's the SOHCAHTOA definition?
Opposite over adjacent.
Opposite or adjacent. Just out of curiosity, which one looks like it fits better? One argument says that this is the sine of theta and this is the cosine of theta. The other argument says that this is the opposite side and this is the adjacent side. Ignore the negative for a second because that's the oddball. Like, let's just pretend the negative's not there. One of these two doesn't make a lot of sense. Yeah.
The opposite, oh. Not by mine.
Okay. Yeah, just pretend it's not negative, just pretend it's positive. One of these two doesn't make a heck of a lot of sense. Yeah,
Opposite over adjacent.
explain.
Actually, I don't know.
Okay. It's courageous guess, by the way. What is the highest value that sine can ever go? Good.
Am I right?
You are right.
One.
1. On the unit circle, sine only goes up to 1. What's the lowest it ever goes? Negative 1. Does it ever go down to radical 17? No, that's too big or too small, depending on point of view. In other words, I would love to use sine over cosine, but these numbers are too big. There's no way cosine ever gets up to 8. The highest it ever goes is what? 1. The highest cosine ever goes is 1 because it goes to the right of the unit circle just one space. So I would have loved to use this, but it's disqualified. This, on the other hand, is a possibility. This is talking about a right triangle. There is something weird about this. Here's where the illegal part comes in. Tangent is equal to negative radical 17 over 8. Opposite over adjacent. Does anybody see anything wrong with that? Yeah.
Is it negative?
Yeah. Everybody is going to, like, if most mathematicians in the world took one look at this board, they would call mental health services on me. 20 minutes later, the nice young men in the white suits would come in and give me the nice suit with wraparound sleeves and take me to a nice rubber room where I won't hurt myself. In other words, that is a problem. There's no such thing. No, don't take me away. It really is negative radical 17 inches long. I saw it in a dream. And then, off I go. So, does everybody understand this isn't really legal? However, you can still do math with it. I mean, imaginary numbers are, proof of that. Somebody do the Pythagorean theorem for me. Just ignore it. It's negative. Just deal with the fact that it's negative. I realize it's kind of like, here, just go ahead and ride the horse. The horse is imaginary. Just ride it anyway. Just pretend. Make believe. So, can somebody do the, Katie, Pythagorean theorem for me? 8 squared. A second. By the way, you're being clever. Yes. Equals what? What would you put? Don't do the math. It's a missing side, so it's c squared. Yeah. What did you get on that one again? Yeah. How do you get that so fast? Yeah, the square and the square root cancel. And what's a negative when you square it? Positive. 8 squared is what again? Equals c squared. So what do you get here? It looks like 81. So what's C?
Oh, no.
9. Does that make sense? It actually worked, even though it's like blatantly illegal mathematically. It still worked. I'll show you what this actually means in real life in a second. But if C is equal to 9, can somebody tell me, oh, I have to, I have to show you something. This is totally evil. Tangent of theta is equal to negative radical 17 over 8. That was one possibility. It could have been that. Let me see why. Because you can put the negative on the other side. So this side, it would look like this. Crummy triangle, sorry. This is negative radical 17, 8, 9. And this one would be just as dumb looking. Negative 8, positive radical 17, you still get 9. Okay, so it doesn't really matter. But I want to show you exactly what these look like in a second. Just be aware that it could have been either way. I want sine, and I want cosine. Is there any way you could give me sine of theta? Just using this picture. Right, go.
Negative radical 17 over 9.
You are correct. Give me cosine while you're at it.
8 over 9.
Now, somebody use this formula and give me my final answer. Let me see. Abby, help me out here. So what is 2 sine of theta times cosine of theta?
So it would be 2 parentheses negative 17, negative radical 17 over 9.
Okay.
And then cosine 8 over 9.
And what is cosine then?
8 over 9.
8 over 9. Good. Multiply for me. This is 2 over 1. The top doesn't do a heck of a lot. The first and last multiply
16
times.
negative radical 17.
So how would you condense that all? So positive times negative is
Negative.
negative. How would you write that? Just put the negative in front, and then what's the two numbers?
16 times radical 17.
Exactly. Over what?
Could you?
Times 9.
There's 81.
Yeah, if they're multiplying, you don't even need to count them. And that is your answer. Does that make sense? It seems like hocus pocus because we used a negative angle. And it really doesn't matter which of these two it is. I will give you a picture of what it looks like, just so you're aware of what's going on. Because one of these is actually accurate and one of them is not. It doesn't really affect our answers. Here's what I'm talking about. Because remember, this is kind of sine of theta. This is kind of cosine of theta. So, did they give us any hint in the original problem, like problem number 6? Did they tell us anything about theta at all? Take a look at the problem. Yeah.
Sine of 9.
Oh, okay. Take a look at, just read the, yeah.
That it's more than or equal to 90 and it's less than 100.
Yeah, it's between 90 and 180. What quadrant is that?
Are you asking me?
Yeah.
What, 2?
Quadrant 2. It's in here somewhere. Which of these, basically, you see this picture? Everybody look up here so you see where I'm pointing. This thing, if this is negative, technically which direction should it be going? If you're graphing it. Like it's up down, but if it's negative, where should it go?
Down.
Down. Here's what it actually should have looked like. This is supposed to be 9 now. Looks like an 8. Does everybody see why? the negative side would have forced you down this way. And if you're looking like a great big huge enlarged unit circle, what quadrant is that? Yeah, it's quadrant 4. Try that trick here. This is a left-right stem, and it's negative. So we technically, here's the center of the circle. Which way should it have been? Man. If you're going left or right and it's negative, which one are you going? Left. What this really should have been is this. -8, radical 17, 9. That's the realistic picture. And if you do an enlarged unit circle, what quadrant is that? Second quadrant. And that's exactly the one we want. So we now know what it looks like. It's not a unit circle because it's bigger, but this is -8, this is radical 17, and it's a radius of 9. Did you see how we got that? So if you need to the nice thing about this is, it really doesn't much matter, because one of these will be positive, one will be negative. But if you multiply them, it doesn't matter which one's negative anyway. It'll just be the answer negative. If both of these are positive or both of these are negative, it doesn't matter. When you multiply them and when you divide them, no biggie. Okay? If for whatever reason you need to find out where you are, just look and see which one is negative. If the up-down is negative, you're going down. You're down here somewhere. If the left-right is negative, you're going to the left. So it's one of these two quadrants. Okay. Righty. I'm going to actually cut this assignment in half. For tomorrow, I would like you to do 1 through 11 odd. In other words, the whole left column. So skip the right column. So you've got 1, 3, 5, 7, 9, 11. Number 9 and number 11 are from yesterday. Find the angle. If it's a half angle, remember we did 22.5 degrees yesterday? That's half of 45. So plug in theta is 45 into the half angle formula, like here. If I want the sine of 22.5, it's the sine of 45 over 2. Plug in a 45 here and get the answer. Make sense? Same thing if you want sine of 247.5. Figure out whatever twice that is. 495? Hold on. 2448. Yes. 495? I think. 24. I'm almost sure it is, but now I'm getting paranoid because they're looking at me like that. So 247.5 times 2. Yeah, it's 495. So number 9, for example, they're looking for half of 495. 495 is a common angle. Find where that is on the unit circle, and then plug it in. Okay. Try your best. You got 10 minutes to hack and slash away at it. Bring any questions tomorrow. Again, just 1, 3, 5, 7, 9, 11. Just the odds, and that should do it. All right, people listening at home, I'll email. It's going to be 1, 3, 5, 7, 9, 11. Just the odds. Take care. God bless. Hope to see you soon. Bye.